Continuing on the topic of testing ideas. So these are now different types of testing ideas. And of course, I like to start with the first type, which I call reconnaissance. And I suppose I took the term from all of the movies I saw about military intelligence trying to learn about situations in World War II, all those movies that kept me entertained in my childhood. And there was always the reconnaissance going on. Someone wanted to know where the tanks were, or where the road was, or where the building was, or where the soldiers were hidden. So reconnaissance was sort of this really cool thing where you gather lots and lots of information. You gather what people called intelligence. And in fact, I thought it was ironic because it's took great intelligence to gather the information, but it was information that you're gathering, not really intelligence. Anyhow, in software testing, we're learning. We're hopefully learning about quality. When we get something new to learn about, maybe we need to learn about what to learn about. So that's where we get reconnaissance. For example, if I receive a product I've never seen or touched before, I may want to try to understand what can this product do. So for me, most common reconnaissance sort of test idea is to identify capabilities and areas of instability in some sort of new piece of technology. So identify capabilities and areas of potential instability, of problem areas. And this is interesting. So you get something new, you've never seen it before, or you've heard only a bit about it, and now you get to try it out. You get to sort of fire it up and start trying to identify what are the capabilities. Now, when I'm doing reconnaissance, it's not good enough for me to make a list. It's not good enough for me to sort of look at the menu and say, aha, there's a way to create a paragraph here. For me to do reconnaissance, I want to know, can it really create a paragraph? So what I will do is I will basically, for each capability that I identify, I will try it with data typical of the intended purpose of the application, whatever that is. And I will basically say, okay, yes, I identified there's a capability to enter a paragraph, and I entered a paragraph, and it was there. And furthermore, when I closed the file and opened it up again, the paragraph was still there, and the paragraph that was there matched the one that I entered. So I'm confident there's a capability for entering paragraphs. Now, there's gazillions of variables associated with that are probably interesting to explore and study and test in depth, but the capability that I identified is the ability to save a paragraph. So this is cool. So I have found a capability of an application. I don't want to just go through the menus and write down there's a list of menus, or go through the help file and say there's a list of things in help file. When I identify a capability, I try it out, and I try to make sure it is really a capability in the device. So recon is what's real. I don't want recon to say what's in the documentation. I want recon to say what's real. And that means also I'll probably find discrepancies. But it's cool. For me, recon, I can get information from all sorts of sources. And what I try to do is also learn, while I'm learning about the application, I'm learning about what the complexities are of the application. Where is the processing really taking place? Is it really entering paragraphs, or maybe it's the formatting, or maybe it's the multilingual stuff? Maybe if I have paragraphs with lots of languages in the same paragraph, that's going to be the sort of the key factor for this application. I don't know. But reconnaissance for me, it's my opening bid. It's a type of testing activity I do early. When I learn something new, I love to do reconnaissance. If I was given an application with a microservice REST API, and I was asked to do some reconnaissance of it, I would write programs. I would write little snippets of code. I would try to identify what are all the endpoints, and what is the payload, and what are the variables in the payload, and what are the capabilities, and do they really work? And I would probably try to pull out documentation, the contract descriptions of the API, and then I'd see, does that match reality? And if it didn't match reality, is there a capability that's not documented that's in there, and find out what the distinctions are. So this for me involves writing programs to try things out, little programs, snippets of code, not something that is going to be a application by itself, but it's a guide to what the capabilities are. It's part of my reconnaissance. So I like to build libraries of these snippets of code. So reconnaissance, my opening bid. And as tester, I always have the picture of the truffle snorting pig to emphasize that what we should be doing is we should be sticking our nose everywhere, looking for test ideas. Stick your nose everywhere. So the next type of test idea, and this is probably the most common one that I see. It's sort of obvious, so maybe people don't even think it's a type of testing ideas. I call it capabilities. When I'm using index cards, almost always I use a green index card for a capability. A capability-based test idea is a test idea that confirms that an application can do something. So you're basically looking at the functionality of the application, and you're saying, basically, can the application do A? Can the application do B? You're basically studying what it's capable of doing. So a capability, you can learn about them usually from requirements. This is definitely requirement driven. Sometimes these requirements are not written down, so you might have to get them implicitly, or you might interview people. If you have formal UML, you may have use cases. If you're agile teams, you may have user stories. All of these point to what are capabilities or capability-based testing ideas. A capability-based test idea, when I'm formulating it also, I can look at it as confirmatory. So I might start saying, all right, this testing idea is to confirm some feature does what it's supposed to do. So confirm, we can save a paragraph. Confirm, we can open a file. Confirm, we can log in. So we're confirming some capability actually does what it's supposed to do. And unfortunately, this is a very common type of test idea. On some projects I look at, when I'm auditing the testing, I look at the test ideas, and all of the test ideas are capabilities. And for me, this is like, okay, it's an important type of test idea, but it's only one of many types of testing ideas. Okay, so the capability-based test idea checks, does the system do what it's supposed to do? Does the system do what it's supposed to do? Capability-based testing ideas focus on confirming that our application does what it's supposed to do. So it's confirmatory in nature. For example, confirm the application can create new users. Confirm transactions can be canceled after approval, but before payment. Confirm that the Wrap-O-Matic can wrap chocolates. These are confirming the application is able to do something. Where do we learn about capabilities? Well, the sources of information are pretty broad. Certainly, documentary evidence exists. In some projects, there is a lot of documentation. Other projects have less. Some people suggest agile projects some of them have hardly any documentation. But in either case, if you have access to manuals, published help systems, a package that has packaging text on the packaging, emails from stakeholders, documents that claim to explain the requirements of a system or the design of the system, even the actual source code of a system or the schema of the database could be great sources of capabilities, capability-based test ideas. You can ask people. Software engineering is all about people. And I would like to say software testing is all about people and the occasional bug. So people, the customers, the users, the system administrators, the database gurus, right? The people manning the help desk, the sales department, programmers, developers, testers, teammates, people who are working with you in marketing and support. All of them have an idea of what the product is supposed to be doing. Some of them have what are called claims. They claim the product can do A. They claim the product can do B. They claim some capability. So once we identify those claims, we can make test ideas which confirm that those claims can indeed be met by the product. So some of this is claims oriented. A person or a document claims our product can do something. Salespeople love those type of test ideas because you're asserting that the claim is true or false. And if you could demonstrate the claim is true, the salesman can use that to his advantage to close the deal. And then there's, of course, testing to identify capabilities. So reconnaissance testing, as I spoke about just a few minutes ago, is an excellent way to find lists of capabilities. You can look at also competitive products, similar products from other vendors. They might give you hints as to what capabilities are or should be in the system. Old versions of the software. Maybe something that we call a gap analysis, where we look at a feature from the perspective of all sorts of different users doing different types of work to try to find out if there's any missing requirements. Affinity analysis, looking at what's similar and what's different between different systems. We can do paired exploratory testing with a subject matter expert to help us to identify capabilities. We can pair with also end users, expert end users, to identify capabilities, and even people involved in administration. I would suggest that marketing and sales also are great candidates to explore with, although if I was given the choice between an expert user and someone in my marketing department, I would really want the expert user first. That's my bias a little bit. So marketing is what they want the product to do so they can sell it. Users are what the product can do so they can do their job. Then we have the notion here of capability test ideas and how they sort of work. You know, how you can construct them. And there's a lot of ways to construct them. So one of the first steps for me in capability-based test ideas is to identify what I would call an object. And then after I find an object, I'm going to try to find an action. Once I've got an object and an action associated with that object, then I'm going to try to find what are the variables related to that. And given I know the object, actions, and variables, I try to relate the object and actions and variables and turn them into questions to confirm the behavior of the system. So the objects are what I call testable objects, are things I can learn about. Testable objects may be a process, screens, forms, pages, features, functions. They are almost always described using nouns in a requirement document. So objects are nouns. And in the book, Charting the Course, Coming Up with Great Test Ideas Just in Time, there's a chapter on capability-based test ideas where I actually go through paragraphs of requirements and I identify testable objects by reading sentences and hunting down what are the nouns of these sentences. So once we've got objects identified, the next step is to try to identify actions. So actions, I hunt for the actions, and the same type of place I hunt for the objects. They're things the software does to the testable objects. They're verbs in the requirement document. They're action words. So our verbs are actions. So having found the objects and actions, I search for variables. A variable, in terms of testing here, a variable is much broader in concept than just a program variable. Here, a variable is anything which can change, and that we assert or that we believe the software behavior depends on the values that the variable takes on, or the software influences the variable. Usually, both cases happen. The software changes the variable changes the software, influences the software. So once we've isolated the variables, we have now an object, action, and variable, we relate them. So capability test ideas explore the relationship between the objects, actions, and variables. And that's basically what it's all about. It's what you want to learn about. So capability-based test ideas confirm some object action pair works with some variables. There's nothing dramatic or complex about them. They're actually relatively straightforward and generally easy to find. Once you identify the application can do something, you can confirm it does that, and you might want to say, okay, well, if you're supposed to be doing things like saving a file, you might say, well, okay, what happens? Can I save a file from different users? Can I? So the user type might be a variable, or the access privilege might be a variable, or the amount of free disk space might be a variable, or the file type might be a variable. And then your capability test ideas all relate to exploring the behavior of the system as these variables change. So capability-based test ideas confirm some feature does what it's supposed to do. Some people used to call that positive testing because it's confirmatory in nature. But I tend not to use the term positive testing. Um, Another type of test idea, and for this one, I generally use red index cards. There's a lot of different shades of red, but I use red index cards for failure modes. Some people would say the failure mode sounds like a negative test idea, but it's not. It's a simulation, really, of something bad. So the failure mode looks at the design and sort of asks, well, what can break? Is there anything in this design that is weak? I wonder how this design reacts to invalid stimulus or invalid input. I wonder how this environment, hardware environment, might impact it. What if we don't have enough memory or storage? What if the network is constrained and there's not enough bandwidth? What if the CPU is saturated? What if there's a lot of shared resources by other applications? So we have the possibility of failure modes. And failure modes lead to interesting discussions of error recovery as well. So in a failure mode test idea, what we generally will do is try to simulate a failure and watch what happens to the system. So you're simulating a failure. This is not the term negative testing. Negative testing is often used to talk about things like failure modes. But for me, failure modes is I'm looking at the design and I'm asking, what if something goes wrong? What if something breaks? What if something goes afoul? So a capability test idea confirms something does what it's required to do. A failure mode challenges, does it do what it's designed to do in different circumstances? What if? Failure modes. So failure mode test ideas focus on learning about the application's behavior when something goes wrong. Failure mode test ideas are what if questions. They're often inspired by how a system is designed. I look at objects, I look at components, I look at processes, I look at interfaces in the system, and I ask myself, what if they break? What if they exhibit some sort of unanticipated failure while someone's trying to use them? Some test ideas, failure mode. For example, what if the system doesn't have enough memory? What if the Rapamatic inbound conveyor belt breaks during production? What if it runs out of paper? What if the spool breaks? What if something goes wrong? These are more examples. Rejected chocolate bins overflowed. Rates of arrival are too fast. Production occurs at really low or really high temperatures. What if something goes continuous operation for 48 hours? And maybe how long can it wrap without failing? These are all types of failure mode test ideas. They're related to it. Now, there's a nice book on software architecture by Taylor Medvedovic and Dags Iffy, excuse my pronunciation. These are basically just beautiful, beautiful descriptions of diagrams used in software architecture. And my favorite of them is the block diagram. I'm a big fan of using block diagram. Block diagram describes computer software systems with basically two elements: blocks, which represent usually objects or processes or process elements, procedures, stored procedures, stuff like that. Those are blocks. And connectors are the lines between them that show the relationship between the blocks. So blocks are basically objects which are visualized, process or service element, and connectors are the relationship between them. So there's different types of blocks and different types of relationships. And if I just move this up a little bit here, there we go. This is my famous chocolate wrapping machine I'm always talking about, the Rapamatic. Here's a block diagram of the software inside of this system. The yellow blocks are process elements that are not part of the system under test. The blue blocks are parts of the system under test. So we see there's a chocolate receiver, a paper receiver, a box receiver, ribbon receiver. These are all different boxes that do elements of the processing. And you will see connected to the box, there's lines or arrows which indicate some sort of relationship, sometimes directional, between the elements. So we know that the report generator is related to the transaction journal manager. The chocolate weight center is related to the rejected chocolate manager. So we have relationships between blocks, and we know this from a block diagram. So when you're trying to look for failure mode test ideas, for me, a good starting point is to work with the architects or work with the programmers and construct a block diagram. And I would build it myself, actually, based on input from people, but you may be able to find some that are already part of the in-process work. It's just I like to sort of construct these myself. It's a model. It's an interesting model. Then once I've got those objects, right, I ask myself, okay, now we have this block diagram. There's all these objects in it, the blue boxes, right? What if the object fails during a transaction? Or what if it doesn't fail, but it's not visible? Or what if it's busy doing something else when you need it? And these are all interesting things that may be very relevant for the application's ability to be fault tolerant, to be robust. Similarly, we might look at the connectors, the relationships between things. So sometimes a connector is actually a call. And you might say, okay, there's parameters in the call. What if they're out of order? What if the return values indicate errors? What if they don't indicate errors? What if the order of execution is changed? What if the procedure is called from the right procedure on the wrong object? What if there's multiple threads accessing concurrently? What if someone is changing the way they reference things and they start doing it by reference instead of values and stuff like that? So there's all sorts of ways a call can be changed and twisted. Events can trigger things. What events happen, and are they different priorities of them? Sometimes these events are triggered by interrupts, and one process would interrupt another one, or one physical device would interrupt another one. And if this event should be running a high priority but has a low priority, what happens? What if it happens out of order or out of sequence? Or what if it didn't take place when it should have? And then there's data. So sometimes data is being pulled. And what if you're pulling data, but it never changes? So is it really being pulled? Maybe there's a bug there and it's stuck and the data is not moving, but it should be. What if the channel to database is closed, so you can't open it? There's some sort of error or a firewall stopping you. And what if it breaks during a transaction? So it was open at the beginning of the transaction, and somewhere in the middle of the transaction, the database goes down, which is an interesting thing to simulate if you want to have a robust system, especially if you're doing financial transactions and the database goes down in the middle of a transaction. Well, what happens? And this, for me, is a beautiful example of a failure mode test idea. Similarly, you might look at access privileges and multi-threading. What if there's a lot of people trying to access at the same time? What if the data is locked? You're waiting for it to be unlocked. It doesn't respond within a reasonable timeout period. This is resource contention problems. Might really lead into nasty standoff situations where multiple processes are waiting for the same data. Or when I'm locking data A, you're locking data B. I need B to use the A, I need A to use B, so you're never going to get anywhere. Connector linkages, so there could be physical or logical problems with the connection between processes. Sorry, but the wire is broken, or there's a lot of noise on the line, or the network is unplugged. You know, what's going on? There could be something wrong with the way things are supposed to physically be linked. There could be problems with processes that have run out of memory. So the process just chokes. It sort of lies there in some sort of state saying, help, give me more memory. I can't work without enough memory. Sometimes there's processes that are basically trying to sort of arbitrate who gets to do what when. These are managing processes. The core of a lot of operating systems are really doing this, trying to say, hey, when is it your turn to use the resource? And they arbitrate this. And sometimes that arbitration logic is buggy, or they never grant one process the resources it needs. Let's see. Then there's maybe the way transactions are routed through the different process elements. There might be different pathways through it that are risky. Maybe one path is failing and another route might be available. So we have the study here always goes down to looking at the objects and the relationships between them and what can break. And the failure mode test idea is basically challenging the software design. The capability is challenging the software requirement. So they're not positive and negative. They're basically failure modes and capabilities. So failure mode, what if something goes wrong? Capabilities, confirm something does what it's supposed to do. So that leads us to the third type of test idea, or the fourth if you count recon as a test idea. Yes, so the fourth one are called quality factors. Quality factors are non-functional attributes of a system. They're characteristics of a system that if that characteristic is not there, or if it is of some sort of diminished quantity, then the whole product could be of limited value or maybe no value at all. So I usually use yellow cards for quality factors. Yellow sort of because it represents caution. So if you looked at the metaphor, green is for capabilities, right? Green, go, capabilities. And we have red, stop, failure mode. And then yellow, caution, quality factors. I think that that's about as far as my metaphor is going to go about the card colors relating to traffic lights. But it does make sense. Quality factors are things that you want to study. Not all quality factors matter. It's very important that on your project that you've really learned from your stakeholders which quality factors matter so that we can figure out how to study them during our project. And so we can look for all sorts of things. Quality factors are often called ilities, mostly because many of them are described with words that end with I-L-I-T-Y, ility, adaptability, accessibility, auditability, availability, interoperability, maintainability, portability, reliability, reusability, scalability, so serviceability, testability, usability. These are all different words that represent non-functional attributes of the system under test. Now, not all non-functional attributes end with ility. Some of them don't, like integrity, for example, doesn't, or maybe today some popular ones like security doesn't. But there's also power consumption, which is a non-functional attribute of the system, which is really critical today. If you make an app and it burns too much power, you're going to be really, really not popular in the market community. And if you look at the variable costs, companies like Facebook, they have huge variable costs related to power consumption at their server farm. So anything they can do to reduce power consumption drops their operating costs and increases their profitability. So power consumption today is a non-functional attribute of some importance on projects. So let's see, looking at some examples. So I've included, there's a chapter in the book, Charting the Course, Coming Up with Great Test Ideas Just in Time, about quality factors. I give tons of examples of non-functional attributes. So this is now just a series of a few examples, like from the world of adaptability and expandability. So the gist of it, the sort of idea of it is confirm that the Rap-O-Matic can correctly create boxes of chocolate using a competing product's manifest, randomly sample manifests from many competitors. So can we adapt to the patterns of our competitors? Accessibility. Study how operator color blindness might impact error rates. Accessibility would be for people who are very often handicapped or infirmed, that they're able to successfully use the software system. Particularly important for government online systems. But in general, you have a lot of people in the population who do have color blindness. So it might be important to see how an operator who's colorblind behaves. Like, can we start the machine, stop the machine, monitor the status of the machine, etc. That's an accessibility test idea. So study how operator color blindness might impact error rates. Auditability. Can an auditor during or after a production run confirm that reports match log data, reports match production results, and log data matches production results? So that's auditability. Availability. Study the Rap-O-Matic availability by performing several trial production runs at maximum duty cycle. And in this case, the suggestion would be the availability would be the uptime over the uptime plus the downtime. This is a computable measure. Continuity. So confirm that the Rap-O-Matic can resume operation after pausing for maintenance, repairs, inspections, or audits. Ensure the accuracy of logs and reports and production results. So continuity of operation. You stopped, you pick it up. Do you pick up where you left off? And are all your logs and audits still valid? Dependability. Confirm that boxes of chocolate are consistently produced correctly for a variety of manifests. So is it dependable? A reliable. Study the Rap-O-Matic reliability by performing several trial production runs at maximum duty cycle under harsh accelerated life conditions and measure the mean time between failures. You might need someone with knowledge of statistics to figure out how to measure that. Just explore whether, this is integrity, explore whether the Rapamatic failures can accidentally corrupt transaction logs or manifest data. So is there integrity? Can we accidentally corrupt our key log files or our key data? Interoperability, confirm that the Rapamatic reports can be exchanged and correctly interpreted by the chocolate manufacturer's MIS system. Can you read it into the MIS system? Does the reporting get processed correctly? Does the Rapamatic interoperate with the MIS system? Maintainability, serviceability, confirm that the Rapamatic firmware can be upgraded to a new revision. Operability, beta test Rapamatic at customer sites and study how well the Rapamatic works with the customer's manufacturing and business processes. Do we operate with their processes? Reusability, confirm that wrapping engine source code can be reused in alternate hardware environments using static analysis techniques to study the code. Portability, explore how the Rapamatic operator console software runs on Windows, Mac, and Linux environment. GIST, scalability here. Experiment with the relationship between the number of wrapping modules and the Rapamatic throughput. How does a change in the throughput relate to the number of wrapping modules? So this is basically scalability. Do we scale? Performance, determine the average throughput, boxes of chocolates per hour, for the most common, what we call the Pareto types of boxes of chocolates. The Pareto list would be, that's the Pareto analysis, which finds you the 20% of the transactions that happen 80% of the time. You'd study lots of production logs to learn this number. And then what you're doing is you're running that set, the most common ones, to try to measure the throughput of the device. Effectiveness and efficiency, well, for different production runs, light, typical, and harsh, study the CPU and memory resource usage over time. So you're modeling the type of production run and looking at how system resources are used. Is it efficient? Robustness, so assess robustness by operator console, user interface attacks, and randomized data entry. What you're going to do here is you're going to simulate a hacker. You might create what's called a chaos monkey or a tool that basically simulates random keystrokes or something like that. You want to see, is it robust? Can someone cause some sort of havoc by introducing weird sequences of operations? Pressing buttons all over the place. Security, ensure that only authorized users can access and manipulate restricted data. For example, the loader should not be allowed to enter a manifest. Testability, perform a design review. Has the software been instrumented to show the progress of each process during a production run? So this is great. You can study the code to see if it's been instrumented so that you can track it and basically have some sort of dashboard. Usability, study how experienced chocolate factory worker who has never been trained to use Rapamatic can accomplish the task of entering manifest with only guidance coming from online help. That's an excellent example of a usability experiment. You take an expert user, you only give them a little bit of online help, no training, nothing, and see if they can do the task. Power consumption, study the battery power consumption by the manifest entry app during entry of typical manifests before a production run. So that's a bunch of examples of non-functional test ideas. Non-functional testing, by the way, is very challenging. It's hard to describe a non-functional requirement. It's hard to test a non-functional requirement, and it's hard to communicate the result. It's hard to interpret the results. Because of that, and it's the challenge of it, unfortunately, many people don't think about it. And I would urge everybody who has ever tried to fulfill any requirement to really try to find out, for that particular requirement, are there any quality factors that matter? And it might just be silly, but you might find out that for some of them, memory use really matters, or some of them response time really matters. And in that case, while you're doing the development of it, you could maybe instrument the code to make it easy to measure. And then during the testing of it, you can sort of look at log files to see, is it within some sort of reasonable norms? So it's instrumenting the code so that it makes it straightforward to measure non-functional attributes of the system. By the way, Tom Gilb wrote a book on the subject of non-functional requirements called Competitive Engineering, and he allows me to share a copy of the PDF of that book with my students, so I'll throw a copy into my course's references for you. But that's particularly interesting if you're interested in non-functional requirements, which is part of non-functional testing, if you will, because you want to study the behavior of the system, assess if it's correct, and if you do have a requirement that can guide what your experiment perhaps should be. So that's non-functional stuff. Recon, looking for test ideas, looking for capabilities, learning something you've never seen before. First one. Capabilities, confirm a feature does what it's supposed to do. Failure mode, study or ask what if something goes wrong, simulate the failure, look at what the result is. And then quality factors, study some attribute of the system in some sort of condition. It's basically set up an experiment, study the behavior, and see if it's consistent with needs or reasonable. So that's the beginning. There's, of course, a whole bunch more types of testing ideas that come up a lot. Usage scenarios is one. I cannot imagine a software project that would not benefit from some usage scenario-based testing ideas. I, given a card choice, usually choose a light blue card for usage scenarios, although that's a bit of an arbitrary choice. There's no real logic behind why I picked light blue. I guess it's because when you buy index cards, they come in light blue, so I picked light blue. Usage scenario test ideas basically are ideas where you study, can the user do their job? And so when you're doing testing around usage scenarios, you're not modeling the software to see if the software can do what it's supposed to do. You're modeling the user and to see if the user can use the software to get their job done. So this is a real cool thing. These type of test ideas, in my view, almost always bubble up to the top of priorities. The user, if they can't do their job with the system, the whole system might be useless. Doesn't matter what all the other capabilities, failure modes, or quality factors are. If the user can't do their job, the whole system is just not worth anything to anybody. So when we're doing test ideas about usage scenarios, and again, there's a whole chapter about this in the draft book, Charting the Course, coming up with great test ideas just in time. So usage scenarios, you identify who are the users and what are they trying to do with the system. And we might use all sorts of mechanisms to describe it. I'm a big fan of using visualization with mind maps, but I'm also a big fan of using storyboards to describe it and identify variations, looking at changes, at decision points and things like that in storyboards. I'm learning more and more about other very similar related things. For example, there's a type of analysis called user domain journey mapping, which is used in marketing to define the relationship between different communities and a product over a life. They call it a journey. And this, to me, is a great source of ideas about usage scenarios. Although some people would say it's parallel to it. I think if I had a journey map, I would be able to identify a lot of usage scenarios. So it's sort of a funky way to identify usage scenarios. Now, a usage scenario test idea is going to challenge the system to see if the user can do their job. Another type of test idea that I use quite frequently and I have great fun with, I call creative testing ideas. So creative testing ideas are basically test ideas which use your imagination and your experience sort of in a hopefully fun way to try to come up with test ideas which would add a lot of value if you ran these tests with probably a reasonable amount of cost. Now, there's a lot of different creative approaches. There's something called lateral thinking. There's a gentleman by the name of De Bono who wrote several books on lateral thinking. And one of the famous ones is called Six Thinking Hats, where you have deliberate creative thinking approaches. There's the whole visualization with mind maps is a creative thinking approach. There's action verb approaches where people would actually randomly take objects and verbs and then say, okay, let's make a transaction that takes this object and this verb and does it, and then you chain those together. So it's action verb testing. You get sort of random sequences of things. I like a random walk. I've actually done this visiting Paris with my wife a couple of years back. Every time we got to a corner, we took €1 out of our pocket and we flipped it. And if it was heads, we went one way, and if it was tails, we went another way. And we really did a wonderful tour of Paris and saw some of the coolest things by following a random walk. Well, a random walk is an interesting type of testing idea, and I would consider that as a creative approach to testing. Now, random walks probably complement other testing, but they will ferret out bugs for sure. You'll ferret out bugs by doing things in sequences like that. Now, the last type I want to share with you of creative ideas is soap opera testing. Imagine your users are characters in a soap opera. A soap opera is a type of television show or a radio show where characters that you can relate to do things that you can relate to, but in unexpected or dramatic fashion. So the soap opera character does things you relate to, but in unexpected or dramatic fashions. So they're sort of like doing something really funky and something wild. And when you look at the soap opera, it's drama. And what really entices you is all these funky, crazy things that happen between people that lead to the plot advancing and lead to conflicts between characters that are just very compelling to watch. Like, you want to find out what's happening next, and you sort of stay tuned, and every day you have to watch your soap opera. And which is great, because that's why they sell soap during these TV shows. They want you to buy lots of soap. Now, soap opera testing ideas are just like that. Imagine your user, and imagine what your user normally does. And take normal things your user does, but do them in dramatic or unusual orders of operations with different dramatic differences in values and sequences and things like that. So if, for example, a normal transaction is for a customer to take out or deposit $100 in an ATM, well, what if that same customer does a whole bunch of transactions at $100 and then does one transaction at $57 million? And you sort of see, well, what was going to happen then? Now, it's not something that's common. It's not something every day, but it could happen. And so let's see what happens. So this is a soap opera testing idea. Very, very popular in the world of insurance software, where they're always trying to imagine weird patterns of deductibility. And I heard someone describing to me really cool soap opera test ideas for people with auto insurance, where they had actually got multiple cars and they're registered in multiple states or provinces, and they're basically registered to different driver's licenses, because there's no law that says you can't have a driver's license in 2 provinces or 2 states at the same time. And so you can have the car registered to different licenses in different states at the same time. And it leads to really weird business rules. And people sort of found great actually holes in decision-making logic in insurance applications by doing that sort of testing, creative testing, with the soap opera ideas of these. Imagine someone has 16 licenses in 16 states and 5 provinces, so 21 in all, and they wanted to buy insurance in each different place. You get all sorts of weird things happening. So can it happen? If it could happen for real, maybe it's something worth exploring. These are fun test ideas to complement perhaps some more systematic ones that we've come up with so far. So just to review quickly, types of testing ideas we've looked at. So recon, learn about what the system can do, identify areas of potential instability. The recon. Capability, confirm the system does something. So confirm it does what it's supposed to do. Failure mode, what if something goes wrong? What if something mucks up? Quality factors, study the behavior in certain conditions. Study non-functional attributes of the system. Do experiments. And the last one we have in this list is creative ideas, where you use your imagination and experience to come up with test scenarios which should challenge the behavior of your software and help you learn about cool bugs quickly. All right, so I'm going to end that section with creative approaches here and pick it up shortly. Thank you very much.